Hi everyone, my name is Christopher. Welcome back to Polynord Engineering. Today I'll show you how to turn an ESP8266 into a Modbus slave to send temperature values over RS485 serial communication. If you've been struggling to find clear guidance on this topic, you're in the right place because this tutorial is as rare as it gets. Believe me when I say that. I've been searching everywhere on how to create ESP8266 as a Modbus slave, and there is almost no information anywhere. So this code has been a lot of failure to success. It took me a long time to figure this out, but I finally did it. Before we dive into the code, let me explain the hardware concepts we'll be working with. Modbus is a communication protocol commonly used in industrial automation to exchange data between devices. Now, the RS485 is the hardware layer that supports Modbus, allowing long-distance and noise-resistant communication. However, the UART pins on the ESP8266 are not directly compatible with RS485. That's where this RS485 to TTL converter comes in. It bridges the gap between the ESP and RS485. In my case, I use a Link 150 Schneider Electric to convert RS485 signals to Modbus TCP IP so my PLC can read them. However, not everyone has a module like this laying around, so I'll focus on the direct RS485 serial communication in this tutorial. Now that you understand the hardware setup, let's dive into the code. This ESPHome configuration turns the ESP8266 into a Modbus slave and exposes temperature readings from a Dallas sensors as Modbus registers. First, we define the basic ESP8266 and Wi-Fi setup, and notice the static IP configuration for stable communication. The next thing we need to do is configure the UART interface for RS485 communication and enable Modbus in server mode. So this is the UART configuration that you have to do. The baud rate, stop bits, data bits, and the parity is what you have to set up if you have a Modbus network, and it needs to be the same for it to read this device. It's pretty basic. This is the slave or server as we call it here. I'll put a link in the description below with the code so you can download it and make it your own if you want to. But the real magic happens here on the Modbus controller. We're using Dallas temperature sensors to measure various temperatures in the heating system, and each sensor is addressed uniquely and its data is scaled for precision. So in this example, the temperature from the GT11 is multiplied by 10. So 25.3 degrees Celsius is represented as 253. This ensures precision when transmitted via Modbus. The Dallas temperature sensors are wired in parallel, sharing a single GPIO pin for data, and it's configured here as a one-wire bus configuration on GPIO 4 on the ESP8266. This simplifies the setup, allowing multiple sensors to operate on one input. I have 6 sensors and it's working perfectly. Before assigning the sensors, we need to find their unique addresses. So upload the following configuration to your ESP8266 to discover the addresses. If you download my code straight off, you have to comment all this out, and you have to comment all my sensors out here. And this is the piece of code that you want to download. If you have one sensor, you'll do this. You download it, you see in the log, you will find the unique address for your Dallas temperature sensors. If you have more than one, like I do, I have 6, I had to put this code in, download it, run the log, find just connect one sensor, find the address, disconnect that sensor and connect next one, find the unique address for the next one, and the next, you get the point, and the next one, and the next one. And when you have all the unique addresses, you just take this code, you paste the address for the temperature sensor, you name it, you give it a unique ID, and when you have done that, you go up here and you paste the unique ID in each sensor here. To test this setup, when you're finished, connect the RS485 bus to a Modbus master device, such as a PLC or a USB to RS485 adapter for your PC. Sorry, it's a lot of PC PLC. If you have a USB to RS485 adapter connected to your PC and use a Modbus testing software like Modbus TCP to verify the data, I'll leave a link to the program in the description also. Modbus TCP. It's a free program, usable for 10 minutes at a time, I think. After 10 minutes you can close it and open it again if you want to continue using it. If you connect your RS485 USB to your computer, you can go into Device Manager and look under Communication Ports. Sometimes it comes up automatically in the connection setup for Modbus TCP. Serial port, your device will show up here somewhere on a COM port. You put the same baud rate, data bits, parity and stop bits as you have in your program here. And then you click OK. Now I have nothing connected, unfortunately, but let's see, I can connect to my Link 150 here. Here you can see I have, so you can see I'm reading from my PLC, my Link 182. Anyway, you get the point with the Modbus TCP program if you want to test. Anyway, so this setup is part of my main water heating system, which I need to be secure and reliable. I just wanted to give you an overview of my heating system. This is basically what I'm trying to achieve. My home assistant runs a thermostat, and by that thermostat I'm setting the set point. My house temperature is an average temperature. It's combined by several Zigbee temperature sensors scattered all over the house, and this is the average that I'm collecting from them. The set point is set in Home Assistant, and it's updating here. If I change in Home Assistant, it will update here, and if I change here, it will update in my Home Assistant. This is an HMI developer program from IX Developer. I'm not too keen of using three systems, my Home Assistant, an HMI system, and my PLC, but this is mainly for my own amusement and to give you a better visual of what I'm trying to achieve. So anyway, to get back to it. My Home Assistant, I will set a set point, and if the temperature goes below my set point, the thermostat will trigger this valve to open to my radiators. At the same time, it will trigger a script that will run for approximately 30 minutes. It will keep this valve open for 30 minutes, and when 30 minutes has passed, the script will execute a trigger to close this valve. After closing the valve, it will wait another 30 to 35 minutes. When this has been closed for 35 minutes, the script will then activate my thermostat again to see if my temperature is above my set point. If that's the case, of course this will continue to be closed. If it hasn't reached the set point, the valve will open again and continue heating. What this is mainly used because I was consuming too much oil, too much energy, and the house, the curve for the house would be up, very high tops, very low bottoms. Now the curve is more smoothened out and I'm not burning as much oil anymore. This is a very old house. The system is very old, but I'm just trying to save as much as I can with what I have. So I came across the idea of controlling the heater as well, because right now I only have one static temperature sensor here that will trigger a start and a stop of the heater, and I can't really read what temperature it is because it's a manual knob and the sensor is very old, and that's why I implemented this, my ESP8266 with 1, 2, 3, 4, 5, 6 temperature sensors. So because when this one is closed, I can have one set point here for my tap water, which doesn't need to be above 55 degrees anyway. When this one is open, I want to have a higher temperature from the burner, and so when this one opens, the set point will automatically jump to another one here and look at this one. So instead of looking at keeping 55 degrees, I will maybe go up to 60 here. All in all, the ESP8266 will send the temperatures, and with the temperatures I can control different set points and stop of the burner. That's pretty much my main goal of this system. And of course, to have the temperature sent via Modbus on a wired setup to my PLC, so even if the Wi-Fi goes down, I can still control my heating system. By using RS485, I ensure stable wired communication with the PLC, avoiding the potential instability of Wi-Fi. I have the program to control my heater in my PLC, and that's why I wanted this setup to have all these temperature sensors connected to be able to run my heater. And that's it. You turn your ESP8266 into a Modbus slave, sending real-time temperature data over RS485 to your PLC or other Modbus master devices. If you find this video helpful, give it a thumbs up and subscribe for more engineering tutorials. Let me know in the comments if you'd like a video on programming the PLC or other Modbus related topics. Until next time, keep building.